2A, Unit 2, beginning session, I guess page 5. Here we go. Explain in words why the following table does not model linear growth. How do I get that back? Oh, that's sweet. I don't even want to do what I'm doing right now. All right, let's put you back where you go. I think you go here, hopefully. And then try and get back to that last page. How many pages did I skip? Am I going in the right direction? Anybody know? There I go. Just right. Linear growth. What am I going to say to them? Let's see, an 11 and 16. All right, let's try this. What do they do to go from here to here, and then from here to here? Someone say it. What are the peers have?
They go tens.
Plus 10. Plus 10. The problem with this is I'm going to make up some numbers on the x side. If the x side was in order, it would look something like this. Let's say the x side was like a, let's put it, if x were 1, I got a 22, then x were 2, I got a 32, then x were 3, I got a 33. It would be linear. In other words, each time I go up 1 here, the same thing happens here. It goes up by 10. I go up another 1 here on the left side. Over here, it goes up by 10. That would be a linear relationship. This one is doing some weird stuff. Like over here, I started at an 11, and that's cool. 11 is 16, so that's a fiver. Let me see. Let's do plus 5. And so it does the 10 thing. If this were another fiver, so that this number would be just the right thing, what's that, 21? If this guy were 21, then yes, linear. In other words, you can't be just hopping around. You can't be like, oh, I'm 16, I'm going down to 5, but he still goes up by 10. So for that reason, it's not linear. So what would I write if I write something down? Why not linear? X coordinates, X numbers? I'm not sure. I'll put hopping around. You put hopping around on your test, I'll give you credit. Hopping around. Don't put an ing out, I'm going to mark you off. Hopping around. Put it in quotes. That way I know you put hopping around. You probably won't find this on a state test. You'll just guess on that one. Hopping around with 2 P's. This frog. The frog has red eyes. They could be contacts. Maybe the frog just has regular brown eyes. If you get contacts, make them look real, because those weird ones will make you look like a lizard. Whatever you're trying to get done, if you're trying to get the whole David thing, no, it doesn't look like it. It looks like a lizard. And people don't like lizards, just so you know. The blue, look at that, like a blue-like thing. The little hand they grip on. You may find this like in the rainforest. Someone go to the Amazon. Is it Amazon rainforest? Yeah, go there and be there, and then come back and say you went. So I get like, dang, you went to the rainforest? You're like, yeah, I went to the rainforest. Did you put that little frog in your hand? Yeah, I put the frog in my hand. And then I'll tell you, they're poisonous, so you're probably going to die. But whatever, you did it. Go and do it. I'd be amazed by you. Let's read the instructions, see what you're trying to get me to write out. I know that 3 weeks is going to be on the bottom. I don't know how to write doubles, but we'll find out. Suppose that currently there are 10 tree frogs in your backyard. My backyard? Oh, I'm going to have to move from that house. How many tree frogs, let's circle that 10, that's important. That's how many you're beginning with. How many tree frogs will there be in 6 months? Okay. Assuming that there are 4 weeks each month. It's a lot of numbers. How about just give me the answer? Anyway, do this. Let me pause, let some people think about it. What do we think the answer is? How many frogs? What's the final question? How many tree frogs will be there in my backyard in 6 months, assuming that there are 4 weeks each month? 1,200. Oh, by the way, if you say the number, don't use the word and. Just say 1,280. And means there's a decimal in there. Not that most of us don't say it that way, but just that I can get credit for making that technical correction. 1,200. I would have guessed that. I would guess something like in the hundreds, but whatever, or like under 100, because it's 10, but I didn't think it through. Anybody else have a number? Like, you don't have to be afraid of her number. We don't know if that's right already. I don't know what the right answer is.
640.
You think 640? I don't know. Anybody got a number like you thought about? You want $20? You can go down to In and Out and buy 4 number ones and eat them all by yourself. Turn one of them into a strawberry shake or a mint. It's on the secret menu.
It is?
No. They got all kinds of stuff in the back. You just gotta ask for it. You guys do like chocolate chip with the mint? I'm sorry, we don't. We will put some burger in it though. All right. It's an animal stuff. All right. Anybody? All right. Let's see. I'm gonna try a little table and see if there's a little pattern. There's gonna be a formula that we all get at some point. So here we go. If I were trying to do it, now that I know on this one. Normally I already know the answer and I just pretend like I'm figuring out as I go along. This one I am. I try a little table thing. Let me see what happens here with the little table thing. Did you use a table, Tina and Raul? How did you guess yours? You just thought about it? What did you do? Just thought about it? Did you just think about it? You did some special math thing?
I mean, I guess I kind of did too. I just did 10 times 2, and then I did that times 2, and then that times 2, and then that times 2.
Oh, I think it is that thing. Yeah, I think it is that thing. So you start with 10. Then we know it doubles every 3 weeks. And so we know that to get down to the next line, you're going to have to multiply it by 2, or 10 is going to double and become a 20. I guess the next 3 weeks is going to double again, times 2, and it's going to become a 40, and that's going to go on for a while. We just got to figure out how long that thing is going to go on, and once we figure out how long it goes on, then we'll find out if it's this 1280 number, or if it's the 640 number. Both are, I guess, good numbers. Here's the math part that they don't say. The beginning number is this moment. Is the beginning of the 3-week period when the next thing is going to happen. So in math, the beginning moment, we put a 0 next to it, and we call it the y-intercept. So whenever you hear the y-intercept, that's what you started with. It's the beginning moment, and if ever you have to write a number next to it, there's always a 0. I don't know how I'm getting to the next part, though. I assume I'm going to write 3 weeks here. Every 3 weeks, it doubles. So I'm going to put a 3. I don't know if that's right. Or should I be putting a 1 for 1 week, then 2 weeks? 1 period. Well, let's see what happens. I'm going to put 2 different numbers. This 3 represents 3 weeks. This 1 represents one of these things. Then 2 is going to represent 2 of these things. 2 groups of, 1 dozen we know is 1 of 12 things. 2 dozens, is 2 of 12, which is 24. So the question is, should we use the actual amount of stuff? Or should we say how many of those things we have? I'm about to find out for the formula. I think it's going to be the green, but I'm going to put down the 6.
Let's just find out how many weeks are in 6 months.
How many are there? 32. 18 or 24? 18 or 24. No? Does anyone know? Is it 18 or 24? Let's figure it out. Oh. Yeah, I guess that forecast. Wait a second. No. All right, so here's the deal. We know in 6 months, that's a mo, there are 4 weeks in a month. So altogether, there are in fact 24 weeks to work with. You okay with that? Okay. Now it's true I'm going to have you take it and just put it in my top drawer. I know you can't help it, but yeah, you got to put it in there. You get it at the end of the class though.
Also, if you divide 24 by 3, you'll see how many times.
Right. Yeah, do it now. What she just said is this. You have 24 weeks total, but what they said is every 3 weeks. How did they get this happened to be? Every 3 weeks, where is it? The thing doubles. So the question, well, how many 3 periods are there? How many of them are there? If you divide this guy by 3, you're going to find out that there are 8. This is going to be terrible. 8 3-week periods. I like to say that. There are 8. So you're going to stand up and you're going to walk back. I can tell whether you're doing it or not. The thing isn't here. I know you took it out. Yeah, I saw it in there. She had hers too, but I missed her when she walked out. She comes back in with it. Boom, she'll put it there too. All right, 8 3-week periods. I'm going to see what the next problem is, because this one from a learning standpoint, sometimes it's too long to be the first one that you do 3-week period. Oh, this is a mess. Here is one thing that's good though. Even if we don't get the answer right now, we are doing Common Core stuff. What is Common Core stuff? Number 1, make sense of the problem and persevere in solving it. In other words, try to figure it out and don't stop after like, no, I don't know. Like write something down. Try to see if you can make sense of the whole thing. All right, so let's see what we got here. There are 8 of these, and so in my mind, I feel that you went down 8 times. The first time, start with that one. Well, let's do this. We're at, is this 1? Or is this 2? You know what I mean?
It's 1.
Okay, good. For those who don't see it, this is at the end of the first 3-week period. So she doubled it from what she started with originally. Oh, so I can see now why this
So
1
there's
is.
8 3-week periods?
8 3 periods.
And why don't you multiply it by 2?
Multiply what by 2?
The 8 times 2 to see how many.
8 times 2. Well, of course, I know it's 16. What does this 16 represent when you're thinking about it?
How many times you have to times it by 2?
How many times?
Double the 8's worth.
Right, and then I just want to see what he's thinking. Just say, okay, no, that's good thinking. You're making sense of that thing. Because you know the 2's are showing up somewhere. You know the 8 is important. Kind of piece them together, but the challenge with that is this. The thing that we're multiplying by 2 is the new thing. In other words, when you multiply the 10 by 2, you get a 20. Somebody else will think, okay, well then multiply the 10 by 2 again to get the next line, but it's the new guy that gets multiplied. So let's go down her line and see that 1280 and see if there was a shorter way. Of course there is a shorter way. There's a formula. You plug it into the formula. You plug it into your calculator and it spits it out. You want to know 8 weeks? You hit in 8 in the place of x, boom, it does it. You want to know 100 weeks? You put in 100 in the place of x. But this is kind of where it comes from. So let's see. We got week 1. And for those who are nervous about math, not good at math, and you're wondering, do I need to know how to do this? No, not quite. We're just experiencing it. Eventually, you're going to learn the little formula. Whenever you need to put something in the formula, like if they say double it, in the formula you're going to put a 2. If they say triple it, in the little formula put a 3. Quadruple it, you'll put a 4, and so on. So don't be nervous about, oh, they're all going to be like this. No, they just decide to start you with hard ones so that when they do the easy stuff, you're happy that they did. In any case, let's see if we can get down this list here. I used too much space down here, so I'm going to do my 10. I'll go all the way up on this frog. Yes, for the record, if you were wondering, yes, some people are eating that frog. Yeah. In France, they eat frogs. Frog legs is a delicacy or whatever. Anybody take frog legs? Frog legs? Okay, I haven't. I don't want to. But I'm sure they would want this frog. Very little bit, you know. So it's not like you're eating like a big meal with them. I don't know what this part of the frog tastes like, but they are doing that with the other part. All right, so we got our times 2. That was I'm going to put a 1. I mean, it's like chicken, you know, or whatever else. Just because we don't do like some people, they eat dog. But I'm eating a cow, little baby cow. It's called veal. Or I'm eating lamb. I'm like, nah, I don't want to eat you. Yeah. So, you know, it just depends on where you were raised, what you think is appropriate. Here it goes. 10 times 2. I want to put a 1 here to represent the first time we did it. 20. 40. I'm going down times, what's after that one? What's after 80? 160. And what number am I on? 1, 2, 3.
It's going to be like 84.
Because from 10, so 0 is the first line, 20. Double 160, please. Say it again?
320.
320. Double 320, somebody.
By what? 640.
640. Oh, there's your 640. Okay, yeah, way to go. 7. Double 640.
Oh, that's the 1280, and we have to go one more time.
Yeah, 1280. And one more.
2560.
2560.
So then we could have done 10 times 2 to the power of 8. That gets you the same answer.
You could have done 10
Times 2 to the power of 8.
10 times 2 to the power of 8. Alright. He is correct, and the formula is going to lead us to that place, and I'm going to say something about it since we got to hear it. What you need to feel about math is this, and I guess it's probably you don't necessarily need for the video, is y equals a times b raised to the x power. Y equals a times b raised to the x power. They're going to make you memorize that one. They're going to give you scenarios. Yeah, and I put it in my top drawer. I know. I just took his too, so he's watching you and I was watching you. So, but at the end, you'll get it right back since nothing's playing. It's neither here nor there. Sorry. In any case, this formula here works. What is the a? They're going to make you memorize it. The a is the y-intercept. This is where you begin. So in this problem, they say, well, we had 10 little x to begin with. So with the formula version, you would know, oh, I'm going to put a 10 in the place of the a. I'm going to multiply that times something. What is the b the base? B the base is, are they doubling it? Are they tripling it? In this particular case, they were doubling it, so you have to know, oh, I'm going to do 10 times 2. And then the last part is, hey, how much is going to be there in 8 weeks? How much is going to be there on the 5th cycle of the whole thing? Whatever that question is, the time question, that's what you put in the exponent. So in this case, it's the 8th one, you put that there. The answer is yes, I think. Wait, she wants to go out and do something here. Oh, no, you just went back. Oh, okay. I thought you were about to shank him and oh, no, did you see that? All right, here goes. And so it is true. Calculators, since they happen to be out, do me a favor, please. Oh, you know what? Let me have you put in the, without the 8. I'm going to have you put in the 8 because in order for your calculator to read this as a formula, go to y equals, type in y equals 10 times 2. The radical button, not radical, the caret button is under the clear. You see the little gray arrows on the right-hand side. You'll see clear. And under that, you see like an upside-down V. Hit that upside-down V. No calculator for you, Andrea. And then put the letter x in that place of that. So again, y equals 10 times 2 raised to the x. Okay, calculate 10 times 2 raised to the x. Once you get that, y equals, show it to someone, double check, see, is mine right? Do I have what you're
What? 10 times 2?
This is the guy right here. So you're going to type in this guy here. Oh, I see, math does take long if you do it right. Okay. 10 times 2. That'd be a great horror movie. They're in the house. Eric, did you hear that? Yeah, what? It's just a couple of frogs. I don't know. Good. Did you hear that? I think it's a frog knocking on the door. That's so stupid. Frogs can't knock on the door. Check it out. I need to go to the door. Close up, any scary movie, close up is when it's going to go down, just in case you didn't know that. Close up. He's looking through the door with the little glass. Frog. Yeah, and then blood. And then frog. They're like zombie frogs or whatever. He's like, I don't know why they're there, but they're like running. Get the guy! And he's running like a frog. And I'm like, he got me! Bye! He shoots out a window. Whatever, yeah. They didn't do 3, 6, 9, the number of weeks. They did 1, 2, 3. How many of those packages do you have? I have 1 3 period, I have another 3 period, I have 3 periods. I'm going to back it up so you guys can fill that in. We're going to try and draw a picture of it. The picture is important. They will ask you to graph one of these guys. The good news is they all kind of do the same thing. It's like roller coasters. They all basically go up and come down. You know, how they get up there, whatever, but they all basically go up and come down. Well, same thing with exponentials. So what is that you're writing in here for those? Like, what do we write? The partners to the 0, 10, 0, 20, 40, write those in down to 6 on your chart. This is it. This is the moment that you're technically doing math, but this is stuff that you'll turn in as math, but really, how could it be? If I just wrote on the board and you wrote it down, how could that really be math work? The blue stuff, you're going to write it on the page that actually has space for it. technically to draw the picture, because there's some people ahead. Can I talk to people who are ahead right now while the people are writing? All right, so we know that was a 20. His partner was a 40, 80, 160. Did they have space below this for you all? Or no? Okay. Put it on to what? 8, 9? I'll go all the way down. Dot. Right down further.
Put 160 for
What?
6.
Yeah, it's 640.
640.
They skipped it.
Oh, I can be like that. Now here's what I'm going to do. To do that in the world of I don't know what world I know this from, but I know if you go like this, it represents the page was torn, and the next thing that came up was something was skipped. What was it, 640? All right. Now you can put it on my desk, all right, so. You ever go by Mars? Ever go by Mars? Consider it. And, so here's the deal. What numbers actually matter? Technically the first 3 numbers, which I don't even think we're going to be able to graph on this thing unless we grade it, graduate it properly. To graduate means to leave school. A graduated cylinder is one that goes up in increments. So to graduate means you're moving up in increments. I'm going to take the top 3. That's Mauricio. He's algebra 2B. After that, he doesn't have to take math anymore. But you are taking pre-cal, yeah? Yeah? Maybe? So yeah, that would say that he's one of the smart. Yeah, that's what one of the smart kids looks like. Yeah, it looks regular. Actually, he does pretty good. He likes to sleep and pass stays up too late. All right, so here's the deal. We turn in the units. For the record, if you would like to sleep in my class, turn in the units. I'm okay with that. Yeah. If you turn in units, I'm all right. I don't know how you're doing it. In any case, first 3 win. The 0, please put a star. E is way important. That's weird. Something isn't quite right. No. It's right. All right, now let me see if I can semi-graph this thing. See if we can get 1, 2, and 3. How am I going to grade this thing? I don't even know if I get to grade it the way I'm going to do. And if it's wrong, ask somebody who knows math and then see what happens. I'm going to make each one of these boxes on the x-axis, the months. I'm going to make them 1, 2, 3 regular. I'm going to make you like 1, make you 2, make you 3. But to get a 20, a 40, and a 10, each one of you have to make you either a 5er. I could do 10, 20, 30, 40. Sure, I'll do 10, 20, 30, 40, see what happens. So I'm going to grade these guys on this side as 10, 20, 30, 40. I'll even do a 50. Okay. So here's the rule, just regular graphing. When x is 0, which is the origin, y, we put a dot there, he's 10, no big deal. Everybody's like, yeah, I did this in elementary school. Yeah, it's true. When it's 1, he jumps up to 20. When he's 2, he jumps up to 40. What is he on 3, anybody? 3. 80, is there an 80? 6, 7, 8. And this, what you see here, is the roller coaster. This is the same ride over and over. Every exponential function will do this thing. It's going to start off like nice and slow. Go up really fast. The numbers increase like way fast. This is why if you could do it, you're my kids and I didn't do it, and nobody's going to do it except 2 people. 80-20 principle. This is why you save money, you put in a savings account right now, or you're like little kids or whatever. When you're 65, your $20 you put in every week or month or $1,000 a year, whatever the small number is. By the time you're 65, it turns to $1 million. That's right, $1 stinking million. Now I'm 44, it's too late for me. You have to start early, like your age, like by 18, 20. It's kind of like the latest. But if you could, I'd love it if someone actually did it. You put the money in the bank in a savings account. You never take it out, and I think you only put in for like 4 or 5 years. So you don't even do it the whole time. You put in whatever the special number is, $2,000 a year, some special number for 5 years, and you stop. You leave it in there until you're 65, and when you're 65, you literally have $1 million in this account. And now what? All your relatives and friends that are poor or whatever, they don't know what they're going to do. You have a stinking $1 million or more. Now they have to borrow from you, and you have to tell them no and all that, and they hate you, but still, you got $1 million in there. How do you draw this picture? I'm going to start with this dot, and do it in blue, do it in red, do it in red. I didn't do it, but I am the kind of guy who would want to do it. It's just that I didn't have enough people around me saying, do it, Thomas. Experiment with it. You're out of the box, do it. I just didn't. Shoot. I wish I did. I'm doing the other thing. I'm doing 10, 10, 80. I'm going to teach you that eventually so you can be good with money. The 80-20 principle, I'm going to kind of do that. Draw this picture. By the way, this black line here, the x-axis, it is an asymptote. Anybody know what an asymptote is? There are only two pieces to the puzzle when you use the function or the equation for an exponential function. There's the letter A and B. You produce A and B, you did it. A is easy. A is the y-intercept. It's where you start. In this problem, I'm going to read it. I'm not going to say you started out with so much of whatever. You started at this place. Initially, you had, wherever you start, boom, that's one of the pieces of the puzzle. Then later on, they say, and it doubled every week, it tripled every week. It did something every such amount of time. Whenever they say that, boom, that's your other number. The famous ones are doubled and tripled. You usually don't go after double and triple. So basically, you're looking for an original number and 2 or 3. You find those two, you're a genius. All right, let's see how they said it in this one. Suppose 30, for those who don't do math, you read it the first time just to hear the story. You read it the second time to see what they're talking about, which, by the way, let me say, so here it comes. Suppose 30 flower beetles, made up, I'm sure, are left undisturbed in a warehouse bin. The beetle population doubles. Ooh, you love to hear some doubles because you know that's a 2. Each week. The function f of x is the name of it. This is like a car. What kind of car do you have? I don't know. It's a Tesla, which I want to buy in 2020. It's a Toyota Camry that I have now. Not exciting, but it was on sale. It's 2015, so it's within last year. It's a Honda Accord, 2010. My wife told me it was the back is ugly, the front is good looking. Tan interior with 2 kids, bad idea. So it used to be tan, now it's brownish, throw up-ish, whatever. They were young. In any case, f of x is just the name of the thing. You don't do any work with the left side, you always work on the right side. Gives the population after x weeks. Gives the population, underline that. So I use this thing to find out how many people are going to be the population. Popular, if you're popular, you're good among the people. In the vote that's going to happen next year, those who are 18 who will vote for Hillary or someone else, you are the popular vote. That is, you're just the regular people. You're not the people who really count. It's the electorate that actually choose the people. But at least you get to feel like you did something. You know. I voted once and but this is my vote count. Here we go. Let's see how we got here. How many beetles will there be? Oh, after 56 days. That's my first reading. I'm going to read it a second time, see the information they gave me, and see how that works. Here it goes. Suppose 34, okay, 30. I know you're going to be my A because that's what we're starting with. Always find my A. That's what I would do if I was a math teacher. 5 years are left undisturbed, so I already got one of them. Look at that. I got my A. The doubles, I got my second one. I'm done. I'm done with the original, the one that I'm going to type into my calculator. This is the one. Once I get my 2 little numbers, then once I have that in my calculator, they're going to ask me about any time frame they want. And as long as I punch in the right number for my x, or if I find that right number on the table, I can find the part. So let's see how they say this. The beetle's population doubles each week. We got that. The function f of x, 30, what? You just gave it to me? Why am I acting like I had to look for something? You just gave it to me? Okay, let me keep reading. Gives the population after x weeks. How many beetles will there be after 56 days? So here comes the question. How many weeks are there in 56 days? How many days in a week?
7.
7. So to find out how many weeks are in 56 days, I do 56 divided by 7. So really what they're asking me, see, this is what I'm trying to say to you. Because they gave us the formula, you got to be careful. Somebody might have just put in a 56 for the x. You got to know what you're putting in for the x. 56 days is how many weeks? I just answered that without even reading it. Good. I'll take it. So we can evaluate the function x for, do me a favor, on your page, put what you think x will be for the question that they're asking. How many in 56 weeks? What number should go in the place? Don't say it yet. In the place of that line. Get ready for it. All right, how many? What should go here? All right. Oh, that's gimme. So how can we evaluate the function for x equals? I'll put an 8 in there, but I need them to feel why there should be an 8 there. What will this whole thing equal in 56 days? We can't put a 56 here because this x represents the number of weeks. So if you turn these days into weeks, and it's that number. So do this. If you haven't done it on your calculator already, please do me a favor. Put y equals 30 times 2 raised to the x power. If you haven't done it already, put in y equals 30 times 2 raised to the x power, not to the 8th power. You put it to the x, and then you're going to go blue button table, and on your table, you're going to find who is the partner to the 8. Again, if all that went too fast, if this 5,120. Therefore, after 56 days, it will be 5,120 BOs. Analyze and explain this is the same or different from this. Ooh, yeah. Let me have you do something. Even though some of you don't know where this number came from, I like this question because it'll tell me whether you know what A means or what A is. On your paper, do me a favor, attempt to respond to this question. I don't know how much space is on there to write it down. What's the new number that we're looking at?
7,680.
This number is the next door neighbor to x equals 8. All right, I'll ask it. This number here. Where did it come?
I put 20. Oh, that's fine.
All right. For the purposes, the 520 won't use, but it came from y equals 20 times 2 to the x. Yeah. So let's say he wrote this down on the test and you wrote it down on the test. I would more than likely, if it was worth multiple points, for sure I'd give him partial credit, recognizing that it was just the 20 that's off. Or I might even give just full credit, because it's what you do once you have the formula that's important. In other words, he knows, get the formula, goes to the line that has the 8, boom, that works. So in a way, even though it was missed, we got it. All right, so let's get some stuff here, some of the important stuff that they're going to ask you over and over. So step 1, this side of the room I'm going to ask you same or different. This side of the room, you have to explain why their answer is right or not. Anybody on this side of the room? These two functions, are they the same or different? All right, different. That's the easy part. All right. This side of the room, someone over here, talking about why are they different? What's different about them?
The exponent is on the different numbers.
Say it one more time.
The exponent is on the different numbers.
And clearly that's a difference. But what makes that difference, since I know that 30 times 2 is 60 and 2 times 30 is also 60, which would seem like they would kind of be the same thing. Why does the exponent be, and this is for the whole crowd anyway, why would the exponent on the different numbers make a difference? Yeah.
Because the first one is saying it's doubled by 2 for however many weeks, and the second one is saying it's being multiplied by 30 for however many weeks.
Right. Whoever the exponent is on, a good explanation there, David, that's the thing that's repeating. That's the thing that changes one number from one stage to the next. In other words, with the 2, we know to get down to the next level, we're multiplying times 2 to get it down to the next level, to the next number in line. Whereas the 30, we'd be multiplying by 30 to get it to the next level in line, as in, where do we do it the first time? Yeah. All right, I'll go back to this guy here. This guy here, of course, we're multiplying times 2 to get down to the next number. To have the x on the 30 means that we'd be doing times 30, times 30, times 30. So they mean quite different things. In other words, if you're getting money, you'd want the x on the 30. That's like you're getting like all kind of crazy money. It's like increasing like crazy. The other one's just increasing by 2, which is still a lot. Because you double your money all the time. That's the one that makes you a millionaire by 65. I didn't do it. Oh, I so wish I would have done it. Higher, dang it. A is y-intercept, B is multiplier. And sometimes the other name they use for multiplier is, what's the other name? Common ratio? Base? I'll put base, but I feel like this is another name that I'm going to have to look up. Base. I'll put common ratio because I know that word, common ratio. Write those down wherever you can. Multiplier, though, you can put a star next to him. I know they use that name. Why is that important? Because if I ask you, is it dame la lápiz? Dame lápiz? No lo? Dámelo? No dámelo? No? But the point is, lápiz, if you hand me the calculator, it doesn't work. You need to know what you're handing me the pencil. This year I'm supposed to learn Spanish extra. Looking for stuff that... 30 years. Doubles every decade. Oh yeah, this one is worth doing. Hey, write down y equals the 5,000 times 2 to the x. The important part on this is what number to put in the x when it's time to get the answer. So this one I'm not going to necessarily have you get the answer to. I just want you to know what goes in that x. Someone is going to be tempted to want to put that 30 in the place of the x. But it's not going to be there. I don't know how many places that goes. So hopefully you wrote this down. You just rewrote this using a y. Y equals 5,000 times 2. Things are doubling every year. Let's see here. They're doubling every decade. Circle decade. That's the key thing there. Why is that the key thing? Because later on it says, let's see, where x is the number of decades. It's the number of decades. Underline x is the number of decades. Models the growth of the value of the investment. Good job on spelling there. How much is the investment worth in 30 years? A better question is, how many decades is 30 years? 3. Yeah. Now this is important because 3 is a number that's going to take the place of x when it's time to figure out the answer. If you're not that good in math, you might go like, well, it's probably just going to be 30, duh. Just put that in there. Look on my table, go all the way down to 30. The part in 30 is whatever. No, so you're going to have to pay attention to who's who and what's what. I'm not getting the answer because I just want you to start feeling a rhythm. How they're going to say it, give you another number that has to be turned into something else, and that's the number that, when you look at this table, will be the answer. So let's see the picture over and over. I'll make this a 1, 2, 3. 1, 2, 3, just so they can see the rhythm of the pictures of any of the exponentials. They always go through 0, 1 when it's just a number as the base. If it's 4 to a power, 10 to a power, 1,000 to a power, it will always go through 0, 1, and there's a reason for that. Because anything raised to the 0 power, when 0 is x, it'll equal 1. We'll show it when they y. B, they call them the base, but I do like a base also, and then we can call them the multiplier. The x, they call them the input, the y, they call them the output, that's fine. Growth factor, oh yeah, base, ooh, yeah, see, all the different names they give it. Base B, draw some stuff on it, mark it up, let your brain see it. It's also called the growth factor. If you can't find that page and mark it up. Let me see what's happening here. Unit 3, I'm going to do homework. The rate of change. I knew B had a bunch of different names. Oh, that's sweet. Unless I didn't want to do that. When would I want to do that? I wonder what circumstances do I want to move this whole thing? B is also called the rate of change, which equals 1 plus the percent. Oh, shoot. Rate of change, we'll say that for another time. There's certain things we do when there are percents in there. And you will have to do it. It will be on the test. So that next thing. So just names right now. B is called a multiplier, rate of change, growth factor. All those things are what a B is. Your favorite, read the problem. Fill in the first blank. It's the second blank that I'm going to help us out on. Your first blank, fill that in. We just need A and B. Once we have A and B, that's the puzzle. So get A. Most people have A or they have no idea. How do you know you don't? Someone say A real fast. The B part goes like this. Circle growth, or grows. If it grows, you're going to do addition. If it what's that the word? If it decays, you're going to do subtraction. If it grows, you're going to do 1 plus the percent after you turn into a decimal. If it declines, you'll do 1 minus the percent once you turn into a decimal. In other words, turn the percent into money and subtract from $1, or turn the percent into money and add it to $1. When it grows, we're going to add the percent when we turn it into money. Let me turn it into money. Turn into a decimal, cross out 1, 2. You want it with 0.04, 4 cents. You're going to add that 4 cents to the dollar. Can anyone tell me how much money I'm going to have right now? Yeah, $1.04 or $1.04. If you think money, some of it won't be so crazy. If it's a growth, your B is going to be $1 and change. If it's a decay, your B is going to be just change. It's going to be 50 cents, 75 cents, it's going to be point something, but it won't be more than $1. All right. How do you write out the formula? Please write out the formula down here. 1.04 raised to the x power. Once you do this add thing, that is your B. So 1.04 raised to the x power. Let me see if define this one after 1 year. You can calculate that times that. I know in 1 year we look on the table where x is a 1, find the partner for 1. In 2 years, where x is a 2, find the partner. Okay. My goal isn't for you to get the answer. My goal is, hey, can I do the formula? Because when I do the formula, oh, they didn't write the formula. Write the formula here for it, please. What are you? Once I can write this, and I got a calculator, any answer they want, basically I'm just checking the x's. What x do you want? You want x is 10? Whatever. X is 100? Okay. X is 2,000? Yeah. But if I don't have this, then x doesn't work. So this is the first time we wrote the formula. We need to write it just to this. Find out whoever A is. Read it, write your A, but don't say it out loud and get someone else to say it on that side of the room. For this one, the B is increased, so that's growing. That's going to be good news. And then we'll write the equation. Yeah, there's a picture that goes with it, but guess what? You get the equation in the calculator, hit graphs, there's your picture. You want to know another answer? Hit table, there's your picture, your answer. So it's the formula that's important. Send me a hand. I have no idea what this dude is talking about. Watch the video at home. Watch it. Dang. I trust you. I'm writing it. 360. This side of the room over here. I'm going to use you as backup, David. Someone tell me what the growth factor is. $1.07. Eventually they might put a percent on it, like something like this. But for now, let's just go with the $1.07. Lastly, the whole room, someone say the exponential function, the formula, please. Y equals. Yeah. What I'm trying to do for you is what I have as a mathematician. I see something in a row several times, like, oh, okay, see, they just keep doing the same thing. So I get the one number, that's the money. The other one, I turn into a decimal, and then I add it. That's it. All right, I'm good in math. That's what math is for those who aren't good in math. You see the pattern, you do it. Do the next one, and then we're done. Fill this one in.